Okay, so today we're going to finish up 8.3. Actually, this entire week we're going to finish up 8.3, and we're going to start with Demoivre's theorem. Demoivre's theorem is about doing powers of complex numbers in polar form. So in order to do that, this is just an extension of the multiplication from last week, so it's not too scary. In order to raise a complex number in polar form to a power, you raise your r to that power and then make sure you multiply that times the n. Just a little note here, usually if your numbers start in polar form, they should end in polar form, and if they start in rectangular form, they should end in rectangular form. Okay, so here's the first problem. We're trying to raise 4 times the cosine of pi over 6 plus I sine pi over 6. I know your book doesn't use this abbreviation, but I don't understand why they don't. It's just so much easier than writing it every single time. So we're trying to find this number to the third power. So we're going to raise the 4 to the third power, and then you're going to multiply your angle by that 3. 4 to the third power is 64. 3 times pi over 6 is pi over 2. So since your answer, since your original problem is in polar form, I'm going to leave my answer in polar form, and you're done. Not too bad. Make sure when you multiply, you might get answers that are over 2 pi. So if it is over 2 pi, you should find a coterminal angle that is between 0 and 2 pi. So this problem is originally in complex form, so we need to put our answer back that way as well. But first, in order to use Demoivre's theorem, we have to change this into polar form. So I'm going to do 1/2 squared plus 1/2 squared. 1/2 squared is 1/4, so we have square root of 2/4, and that is equal to the square root of 2 over 2. To find the angle, the tangent of theta equals 1/2 over 1/2, or 1. So theta, where does tangent equal 1 in the first quadrant? It is pi over 4. So our angle is, not our angle, our complex number in polar form is square root 2 over 2, cis pi over 4. So in order to do to the 12th power, we need to take square root 2 over 2 to the 12th power, and then we need to multiply our angle by 12. Now, lucky for you, you all are at home, and I can't tell if you're using a calculator, but I would expect that you should be able to do the square root of 2 over 2 to the 12th power in your head. To the 12th power, you have square root of 2 times square root of 2 times square root of 2 times square root of 2. For every 2 of these, you would have 1, 2. So the top ends up being 2 to the 6th power. The bottom ends up being 2 to the 12th power. Cis, and then 12 times pi over 4 is 3 pi. Why am I writing that so small? So 2 to the 6th power over to 2 to the 12th power, if you subtract that, that is 1 over 2 to the 6th power, or 1 over 64. I'm going to change 3 pi. 3 pi is the same thing as pi. So that would be your answer if we were leaving it in polar form. So depending on, just pay attention to what the directions say. If not, we could change that. Don't forget that cis stands for cosine of pi plus I sine pi. The cosine of pi is -1, and I sine pi is, or sine of pi is 0. So all of that work to find out that the 12th power of 1/2 plus 1/2 I is -1/64. Lots of work for an answer that you can get on your calculator. So I believe, let's see if I just wanted to show you that you could have done that on your calculator. Not all of them turn out that nicely, especially when you have a imaginary part. They tend to flip out when you do to the 12th power. But just to confirm, this answer is exactly the same. There's an I. Make sure your calculator is in complex mode. So down here you have real, you have complex mode. And then when you do it, the I is down here above the decimal point. Okay. Last example of this, same idea. I'm doing more where they're in rectangular mode just because you have a little bit more work to do in order to do that. But otherwise, it's just that middle steps instead. Okay, so we need to do the square root of 1 squared plus negative square root of 3 squared, which I believe is square root of 4, which is 2. And then we need to do the tangent of theta equals negative square root 3 over 1. Where does the tangent of theta equal negative square root 3? It is some pi over 3, but it needs to be in the fourth quadrant because this number is in the fourth quadrant. It would be to the right and down. So that would be 5 pi over 3. So our point is 2 in polar form, 2 cis 5 pi over 3. If we are raising that to the fifth power, we need to do 2 to the fifth power, and then we need to multiply our angle times 5. So this ends up being 32 cis 25 pi over 3. 25 pi over 3 is not in the unit circle. So if we count by sixes, 6 pi over 3, we get all the way up to 24 pi over 3, and then we would have 1 pi over 3 left over. Reminder to change it back. Going over here, we have 32 cosine of pi over 3 plus I sine of pi over 3. Pi over 3 cosine is a half. And sine is square root 3 over 2. 32 times a half is 16. And then this would be 16 squared 3i. There you go. Like I said, if it were already in if we started here, then you would have to just end here and you can be done. So it's not too much work. I showed you a couple of the longer ones just so that you could get the extra steps at the beginning, at the end, which is what we did last week, but just to remind you how to do that. That's it.